Welcome to the workshop. Today we want to take a look at coloring a graph. So we want to start by looking at an example that's kind of an application as well, introducing us to the idea of what coloring a graph is. So let's consider the following student organization and their members. So on Worship Arts team we have Justin, Mel C, and JC. In the Math Club we have Emma, Justin, Chris, and Jerry. In the Game Board Guild, we have Mel C, JC, Emma, and Mel B. In the Table Tennis Club, we have Mel B, Victoria, Joey, and Lance. And then finally in the Nursing Club, we have Jerry, Justin, and Chris. Now, what we want to do here is we want to determine if each organization wants to hold a 1-hour meeting, what's the minimum number of time slots that can be used? So, for example, could all of these organizations hold a meeting at the same time using just one time slot? Well, of course not. For example, the Worship Arts team and Math Club could not meet at the same time because Justin is on both of those, or in both of those organizations. So they wouldn't have everybody there. So we don't want that situation to occur where Justin can't make it to both of the meetings. So we want to determine what's the minimum number. Now, we've decided that's not 1 because we need more than that. But we know that worst case scenario, if each of the organizations held a meeting at a different time, then that would be perfectly acceptable and we would have 5 different meeting times, or 5 different time slots. But can we get less than that? So it's going to be more than 1. Can we get less than 5? And the answer is yes. Yes, we can have less than 5. So what we want to do is we want to create a graph to represent our situation. So we're going to take a look at the Worship Arts team, and we're going to look at the Math Club. Let's put Math Club down here. And we will look at the Game Board Guild. Now we also have the Table Tennis Club and the Nursing Club. And 1, 2, 3. Yes, table tennis and nursing. So we have table tennis and the nursing club. So that's all 5 of our organizations, and we want to connect them using that 2 organizations are connected if they have a member in common. So we have a collection of vertices, 5 vertices, and these vertices are connected, or they are adjacent to one another, if they have a member in common. So Worship Arts team and Math Club are connected because Justin is on both of them. Worship Arts team and Math Club. Excellent. And then the Worship Arts team is connected to the Game Board Guild as well because Mel C is in both of them. And the Worship Arts team, let's see here, is it connected to the Table Tennis Club? It is not. They have no members in common. And then the Worship Arts team is also connected to the Nursing Club because, again, Justin is in both of them. Excellent. So now we can continue on in this way. The Math Club, what is the Math Club connected to? Well, we already know it's connected to the Worship Arts team. We can see that it's connected to the Game Board Guild because Emma is in both of these clubs. And then the Math Club, let's see, Justin is also in the Nursing Club. So that gives us that. And Chris is also in the Nursing Club. Jerry is also in the Nursing Club. Oh, wow. Hey, quite a bit of overlap between the Math Club and Nursing Club. Excellent. Okay, so we have everything for the Math Club. Now the Game Board Guild, we already know is connected to the Math Club and the Worship Arts team. So we go below to see, is it connected to the Table Tennis Club? Yes, it is, because Mel B is in both. And then we take a look down here, Mel C, JC, Emma, and Mel B. None of them are in the Nursing Club. So it's not connected to the Nursing Club. And then, let's see, moving down to here, the Table Tennis Club, we already know that it is only connected to the Game Board Guild, not connected to worship arts, not connected to math, so we just need to check against the nursing club. And they have Mel B, Victoria, Joey, Lance, not connected. Table tennis club and nursing club are not connected. Excellent. So this gives us our graph for the situation. Now, what does this mean for us? Well, if two vertices or two organizations are adjacent to one another, and they have members in common, and they cannot meet at the same time. So let's say we have a collection of time slots. So time slots. Of course, we need at least one. So let's start with time slot A and assign time slot A to the worship arts team. Then we know that the nursing club and the math club cannot meet at time A. So we need at least one more. B, let's assign time slot B to the nursing club. And then to determine what time slot the math club can hold their meeting at, we need to determine if they can hold their meeting at the same time as the worship arts and the nursing club. Of course, math club is adjacent to both of those, so we need another time slot as well. So add time slot C, because the math club cannot meet at the same time as the worship arts team or the nursing club. Same goes for worship arts team holding their meeting at the same time as nursing club and math club, and nursing club holding their meeting at the same time as worship arts team or math club. So we have this situation, this triangle prevents us from having any less than 3 times. We see another triangle here, and because this vertex is not adjacent to this vertex, we can actually assign that the same time slot. The game board guild can meet at the same time as the nursing club. And now for the table tennis club, their only restriction is that they can't meet during time slot B. They cannot meet the same time as the game board guild. So that gives us the option of time slot A or time slot B. Choosing arbitrarily, we can say A. But that assigns a time slot to each of the organizations, and we can find ourselves having only 3 time slots as the minimum number of time slots that these organizations can have their meeting. Now, this labeling of time slot A, B, and C is typically referred to as colors. So we could have said red, orange, and blue, for example, giving 3 distinct labelings to each of these vertices. And when we want to color a graph, we are just referring to assigning a color to each vertex, in which adjacent vertices do not have the same color. That is, adjacent vertices have different colors assigned to them. So that is the coloring of a graph, and this is an example of it. Helps us determine when meetings can take place, that sort of thing. All right, there will be more to this section shortly, so enjoy your day, and I'll see you guys soon.